find the exact value without using a calculator. So they want us to know what this is equal to. Now, if you recall, the log is equal to the exponent. Okay, to remind you of the logarithm, the two equivalent equations, the log in logarithmic form and exponential form, the log equal to the exponent in this case y. You can, if you want, to name it any variable, but since the exponent is y here, let's set it equal to y. And this is equivalent in logarithmic, in exponential form would be 11 raised to the y power equal to 1. Now, what would y equal to? Recall from algebra the laws of exponent. If a number other than 0 raised to the 0 power, and that's equal to 1. So a to the 0 equal to 1 as long as a is not 0. So a could be any number. So y in this case must be equal to 0. 11 to the 0 would be to 1. So then the exact value of this equal to 0. Now doing the same thing for the second problem, again the logarithm is equal to the exponent. Let's set it equal to y, or you may choose to call it another variable. So it's really up to you. Let's go ahead and use call it z in this case. So writing in exponential form, 8 is the base, and z is the exponent, and 2 is a number. So this is equivalent to 8 to the z equal to 2. Now, how can I go from 8 to 2? What would z have to be equal to? Remember here, 2 is a smaller number than 8, so we cannot raise it to a power greater than 1. And it cannot be 1 or greater than 1. So we're looking here at a fraction. So what do I get? How do I go from 8 to 2? So rational exponent. We have a rational exponent that's equivalent. That's the same as a radical. We can change it to radical. If you recall, cube root of 8 is equal to 2. That's what you have here. Cube root of 8 is equal to 2. And writing it in rational exponent, that's the same as 8 to the 1/3 equal to 2. That means z must be equal to 1/3. So the log a2 equal to 1/3.